So my name is Damien Cassou. I'm not the main responsible for the work I'm going to present. The main guy behind this work is Nicolas Peton. He's unfortunately abroad right now, so I'm going to do the presentation for him. Okay. And Stéphane Ducasse is the head of the research group, and he's having another presentation at the same time in Paris. So here I am. So I'm part of INRIA, and I'm going to present the SAFE work that we have that Nicolas has done. So the main idea is to sandbox unsafe scripts, unsafe JavaScript scripts. So the context: imagine you have a web page, any web page. This one presents a development environment and a programming language named Faro. And on this web page, you would like widgets. So one possible widget would be Twitter widgets, which displays tweets related to the project. And another widget would be the Holo widgets, which displays some statistics about your open source project. Okay, to include widgets, usually we reference a JavaScript file somewhere on the web. So we just include this JavaScript file, and then things are displayed on the web page. So very easy. Everyone does that. It works. The problem starts when you can enter some important information on the web page. So if you can enter the login and the password to log on the web page, then nothing prevents these widgets from reading what you are entering. Okay, so maybe you can trust Holo, but at some point they might get cracked, and a cracker can enter his own JavaScript file on the Holo server, and this JavaScript file could log everything that users enter on the web page. So the cracker in this case could get the login and the password for your website. Okay. So basically, all the JavaScript stuff that you include in your page can access everything on the web page. So that's a problem. There have been some solutions for this problem, and none of them really recognized and solves this stuff. So nothing is perfect as far as I understood. I'm not expert in this domain, so. Yes, so what you need really is isolation of these unsafe scripts so that they cannot access anything that you don't want them to access. In the domain of system administration, this is called virtualization. So they use virtualization to solve this particular problem. So you can run applications instead of running all applications on the same server, where each application could crack the others. Each run on a virtualized operating system, and they are isolated. So yes, what we want is isolation. And our solution to isolation is called SAFE. So we want to isolate unsafe JavaScript scripts. So basically how it works. So on the web page, we have some empty places, and we would like to have this stuff inside. But what we do is that we create a jail where we include the JavaScript file that we want to be executed. At some point, this will create the widget that we will get back here. Okay. The idea is that if Holo is cracked, then the JavaScript here can only accept this blank web page which doesn't contain any information. Okay. So there is no way from cracked Holo scripts to access the login and password from here. How did Nicolas implement that? So that's what I'm going to present now. Imagine you have this web page. In your web browser, it looks like this. So you have a main JavaScript thread with the DOM. So I will enter into a bit more detail what the DOM exactly. But let's say that it's a representation. It's a tree representation of the web page. With all the nodes of the web page representing the tags, and the SAFE.js.lib, so that's a JavaScript library that Nicolas worked on. So the first step is for the SAFE.js library to create a jail. Okay, and this jail will first create what we call the SAFE.js virtual DOM. So the SAFE.js virtual DOM looks very similar to a plain DOM, but only contains the information that we want to give to the unsafe script. Okay, so in particular, we don't want to give it the login and passwords information, so we are not going to put that in the DOM. Okay, basically, we can only put there the div that we want to let the widget in. Then, so the jailbreaker first creates the VDOM with only the important information, and then the jail creates loads the unsafe script. So the unsafe script is executed. It will take some time, do some requests on any servers. We don't care, and at some point the unsafe script will update the DOM. Okay. For the unsafe script does not know that this is not a full DOM. We give it what looks exactly like a DOM, but it's not. So the unsafe script can use the same API that he can use if he would be there. It's exactly the same API, so it's totally transparent. But so the information here is very, very limited. So at some point, eventually the unsafe script will update the VDOM with the widget. The VDOM will convert this update into a message, into a text message. So the content of the widget is serialized in the message queue. Okay, I think the application just crashed. Oh, I don't know. So yes. The update of the web page is serialized to the message queue as text. Then at some point the SAFE.js lib will read this update from the message queue, will update the real DOM, and the web browser will add the widget on the page. Okay, why is it safe? I told you, here we only have the important information. Okay, nothing else. So let's see it again. So we have two jails, each with their own unsafe scripts. They create the widget. The widget is serialized, written on the message queue, and then at some point they are read from the message queue, and the web page is updated with the widgets. Most of the time, crackers don't want to let users see that they have cracked the server. Okay, because if this is very visible that the Holo server has been cracked, then people will notice it very soon and will try to fix it very soon. So most of the time, crackers will let the widget just as it was, except that they do some more things and they try to steal information. Which means that even if the Holo website has been cracked, for the user, still the widget is present. Except that, when Holo has been cracked, there is nothing to steal. It's totally blank web page. Okay, so a little bit more information about the technologies we used. So the DOM is a document object model. It represents the HTML of your web page. It's a W3C specification, so something official that all web browsers respect. It represents the HTML document and it provides an API to manipulate the document. I mean, adding node, removing node, changing node, stuff like that. What Nicolas has done is a SAFE.js virtual DOM. It's exactly the same API. Clients cannot see the difference between the real DOM and the virtual DOM. So it implements the full specification, except that we can configure what's inside. We don't put all the information, but just a subset of the information. Except also that it writes all the changes to the message queue. The implementation of SafeJS VDOM is based on a Node.js technology named GSDOM, plus many changes to make it work on web browsers. Okay, our work also is also based on web workers. So web workers are a background process of the web browser. This is totally new specification. It's draft, so it still can change in the future. So the idea is that the web worker can communicate with the main JavaScript thread only through text writing strings. Okay, so it cannot access, in particular, it cannot access the DOM and modify the DOM. So yes, it cannot access the documents. Nicolas' jail worker is exactly the same. So we use this technology, but we add this virtual DOM, which means that now we can put any script here that will act on the VDOM as if it was the real DOM, and works. And yeah, so we reuse this, the web worker stuff. So to conclude, our contribution is an implementation of the DOM, full specification, except that it can be configured, so we can decide what to put inside and what not. This VDOM writes every change to the message queue. Then another contribution is the jail worker. So it's just like a web worker, except that there is the VDOM inside that can be configured for unsafe scripts. And we also have a tech report that gives some details about the implementation, how it works, and the different technologies that we use. Okay, so more details than in this presentation. So don't hesitate to search for that on the web, and you will find the tech report. What are the limitations of our approach? The first one and the largest one is because it's based on a draft specification, and because it's draft, it can change. So maybe tomorrow the draft will totally change, and SafeJS won't be able to be implemented as we did. So that we don't know, and we don't control. Now we are quite confident that the technology will stay a bit stable, and it's already implemented in many web browsers. So it probably will stay stable, but we don't know. And it only solves document access security issues, meaning that we prevent the unsafe script from reading what is on the web page, but other kind of security issues like reading the cookies, we don't fix. So that's the end of my presentations. Thank you very much for your attention. I'm open to questions, except that I'm not the main author, so I'm not sure I can help. But yes.
You told us about the web workers being a draft. There is another draft, kind of similar to the goal you're trying to achieve, which are the web components.
Okay.
Have you?
Not me. Maybe Nicolas, but I have no idea.
Because there is a part of the API which is about shadow DOM, and shadow DOM kind of results in what you are doing through a virtual job in a web worker. So it's a part of the DOM that executes scripts in itself, and which can't be accessed by the global DOM.
Okay. So does that replace what we have done completely, or you don't know?
It was released after they implemented it.
Yeah.
And it goes, and it seems it's true. It seems to do similar things.
It's close, but as you said, I think web worker is about to be standardized for good, and shadow DOM is still a draft.
Okay.
Nice. So it's very similar. And so the big question in what you did is that the limitation of SafeJS is that web worker can still access cookies, so it doesn't solve problems of security where the component accesses the server. So has the team done anything to push towards W3C, ability to restrict security of web workers?
I have no idea about that. I really don't know. What I heard is that when Nicolas did SafeJS, it was about preventing access from the documents, and not from preventing access for cookies. So I don't know.
but still it's a big limitation. So it's good and limited. It's not difficult to submit proposals to W3C, especially with companies around you.
Okay.
It would be great that the idea of the limitation of SafeJS could lead to a proposal of change or improvement of
Okay.
W3C standards.
Okay, so you propose that we contact W3C?
Yeah.
Okay.
Else it's like your work becomes. There are two ways for your work to become useless. One is changing web worker specification that removes the isolation of web worker,
Mm-hmm.
and SafeJS becomes useless.
Yeah.
And another, everything is always possible.
Sure.
So you can request
That would not be
anything.
like
So
that.
at least by showing, hey, with SafeJS we use web workers isolation to do good things, that helps keeping the current specification. And the other could be that it would be good if we could allocate web workers that don't have access to the request full context.
Mm-hmm. Yeah.
Then that's just a proposal of change of options in the web worker API.
Okay.
And being part of the INRIA should be much easier, not difficult.
Okay, I will propose the idea. Anything else? Good. Thank you very much.